All right, so in the video, I am going to be recording simplifying radicals. Your iExcel.
Okay.
And so before you start with the notes, you want to first look at the screen and make sure you have one of these already written with your 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16. Remember, a perfect square is simply saying 2 times 2 is equal to 4. 3 times 3 is equal to 9. So a perfect square is a number times itself. The number cubed is the number times the number times the number. So the number multiplied 3 times, as 3 is the exponent. You want to have yourself a little chart. It's going to help you. So you want a perfect square chart. And a perfect cube chart. All right. Pause and copy as needed so that you have your perfect square and your perfect cube. When you are done, we're going to get started with the actual notes. And I'm going to share that now. So share. All right, so here we go. Now that you have your chart, we're going to be simplifying radicals. If the radical is not a perfect square or a perfect root, it doesn't get an exact whole number. So if I asked you what the square root of 12 was, well, we don't know. It's not a perfect square. I know it should fall between the square root of 9, which is 3, and the square root of 16, which is 4. Somewhere between there. The answer is going to be closer to around 3.5, 3.4. We could make an estimate because we don't know the exact square root of 12. All right, so we know this is going to be approximately 3.4, something of the sort. But we're working with approximations. If we want an exact answer, not a decimal, then we have to do what's called simplifying the radical. To simplify the radical, you want to look at the square root of 150. We're going to simplify it. Well, the number is 150. Find the factors of 150, meaning what times what will give you that. Let's see. Maybe you're thinking. So there's 5 times 30. That does give me 150. But if you look at your perfect square chart, none of those are a perfect square. Maybe we have 10 times 15. Those are factors of 150, but none of them are a perfect square. It's not going to work. So maybe we want to try 75 times 2. That equals 150. None of them are a perfect square. Maybe I want to try 25 times 6. Yes, it's a factor of 150. And 25 you should recognize as a perfect square. If that's the case, then we can break the square root of 150 into the square root of 25 times the square root of 6. So I've broken this apart into 2 different factors, in a sense. Now, I like to put the perfect square first because it helps. The square root of 25 is a number. The square root of 25 is 5 because 5 times 5 is 25. And then we have the square root of 6 that's left over. Now, let's see if we could break down the square root of 6 some more. Factors of 6 are 6 and 1, and 2 and 3. And none of those are perfect squares. So I know this is my final answer. 5 radical 6. Let's look at the square root of 180. Again, first, let's find the factors of 180. You think of some factors. Maybe there's 60 and 3. True. None of those are perfect squares. You keep going. 30 and 6, not a perfect square. Keep going. 90 and 2, not perfect squares. Keep going. 9 and 20. Ooh, 9 is a perfect square. All right, let's see what else we've got. Maybe 10 and 18. None of those are perfect squares. So I'm going to try and go with my 9 and 20. If I do that, I can break this apart. It's always freezing, but you're taking a test. Don't let everybody online know you're taking a test, girl. The square root of 9 and the square root of 20. The square root of 9 is a perfect square. The square root of 9 is 3. So I know that this is 3 as a whole number. And then we have the square root of 20. I could be done, but I'm not sure. I always want to try that second number just to be sure. All right. So now I'm going to look at the 20. Factors of 20, 10 and 2. None of those are perfect squares. What else we got? 4 and 5. 4 is a perfect square. So the 20 can now be broken into the square root of 4 and the square root of 5. 5 times 4 is 20. I already had the 3, so I still have my 3 out here. And it's 3 times the square root of 4 times the square root of 5. Well, what is the square root of 4? It's 2. So now we have 3 times 2 times the square root of 5. My final answer is 6 radical 5 when I simplify it. To be fair, Miss Reed, or you, if you knew up here that you had 180 could be factored into 36 times 5, then you would have saved this extra step. But if you don't, you just continue to simplify all the way. Now you go ahead and try number 3. Pause the video and try number 3 on your own. Um, 160 was broken into 16 times 10. So I brought this into 16 and the square root of 10. The square root of 16 is 4. So then we had 4 radical 10. I'm going to try out the 10 over here. That's 2 times 5 and 10 times 1. None of those are perfect square. So this is as far as I can go when it is simplified. Now the perfect cube is going to behave in a similar way, but make sure you're using your perfect cube. A number times a number times a number. So first we see here that we want the cubed root of 16. I'm going to find the factors of 16. Oh, let me do the cubes in a different color. Orange. So factors of 16, I do have 16 and 1. I have 4 and 4. And then I see that these are perfect squares, not to be confused with your perfect cubes, because now we're looking for, again, the cubed root. So that's not a perfect cube. That's not a perfect cube. Maybe we have 8 and 2, and then we see that 8 is a perfect cube. So the 16 I can break into the cubed root of 8 times the cubed root of 2. And the cubed root of 8 is a number. It's 2. And then I have cubed root of 2. So now I can look at the factors of 2, which is just 2 and 1. I know I can't break that down anymore because 2 is not a perfect cube. And so I am done with this simplifying. I'm going to try number 5. Let's get the hang of it. And that's 192. So again, factors of 192. Let's see what we got. 8, 64 and 3. 64 and 3. So if I look, oh, I think that's it. 64 times 3. 64 is the cubed root. And so I have the cubed root of 64 times the cubed root of 3. And then cubed root of 64 is 4. And the cubed root of 3, I cannot do. Let's see. 3, oops, just 3 and 1. And that's not a perfect cube. So then it's the cubed root of 3. And that's my final answer. Go ahead and try number 6 all by yourself. Pause it and try it. All right, so when you are done, you should have 5 and the cubed root of 2. All right, so this gets broken into the cubed root of 125 and the cubed root of 2, because the factors of 250 was 125 and 2. All right, now let's talk about multiplying. How do we multiply them? When you multiply radicals, we're going to multiply the numbers first. Then we're going to multiply underneath the radical. Just like before, we're also going to simplify. All right, it can be done in a mixed order. So let's look at number 1. Number 1 is here. I have 2 radical 2 times 3 radical 2. I'm going to multiply the numbers first. 2 and 3 are the numbers in the front being multiplied. Everything is being multiplied. That's why I could do the numbers first. So 2 times 3 is going to give us 6. And then I'm left with these radicals. Well, to multiply radicals, I multiply underneath the radical. Let me give that a different color for you. I multiply underneath the radical. So 2 times 2 is going to give me the square root of 4. Can I simplify that? Yeah, because now I know the square root of 4 is a number. It's 2. So now I have 6 and the square root of 4, which is 2. And 6 times 2 is 12. Let's see it again. In this case, I want us to see it, but I also want us to look at it. I have 4 times the square root of 3 times the square root of 4. Now, if I'm going to go 4 times 1, maybe I could do that, but let's go ahead. 4 times 1, because if I don't see the number, it's because there's only 1, 4. And then I'm going to multiply underneath the radical, 3 times 4. And that's how I'm going to get the square root of 12. Then I'm going to go ahead and simplify this. Well, factors of 12, 3 and 4, 12 and 1, 6 and 2. Any of those perfect squares? Nope, nope. Here, the 4 is a perfect square. So I'm going to break apart the 12 into the square root of 4 and the square root of 3. 4 times 3 is 12. Square root of 4 is a number. It's 2. So I have 4 times 2 times the square root of 3. And my answer is 8 square root of 3. I want to point out another way, because if I notice the square root of 4 from the beginning, I could have just said this is 4 square root of 3 times 2, because the square root of 4 is a number, it's 2. And in that case, I would still multiply the numbers first and get 8, and then I would just have the square root of 3. Same answer. It depends on what you saw first. All right, so here we go. We are looking at number 3. I think I'll let you try it. No, I think I'll try it with you. I'll pause and try number 3. Now that you have paused and completed number 3, you're going to numbers first. That means 8 times 3 gets multiplied, and we are going to have 24. Then you multiply under the radical. So 5 times 8 is going to give us the square root of 40. I could be done, but let me see if I can simplify the 40. How do we get 40? There's 20 times 2. And there is 4 times 10. I'm trying to get some other ones beforehand. Oh, and there's 40 times 1. Oh, there's also 8 times 5. Well, I just did that, so 8 times 5. None of these are perfect square, not perfect square, not perfect square. Here is a perfect square. It's 4. So then we would have 24 times the square root of 4 times the square root of 10. And also feel free to fast forward me. You could put me on 1.5. You can make me speed up and put me on 2. Whatever you delight in. So now we have 24 times the square root of 4, which is 2. And then we have the square root of 10. Well, 24 times 2 is a number. It's 48. So we have the answer, 48 times 10. Let me see if I could break down 10 some more. It's 5 and 2, 10 and 1. Nope, nope. None of those are perfect square. And the more you do it, you will realize as well that the some numbers, you'll begin to recognize those that are simplified all the way. Right. All right, let's look at the cubed root. These are very similar concept. First, you multiply the whole number again. So we get 20. And the cubed root of 36. Well, I know my 20 is there. Let's see if I can simplify the 36. Always try. That's 36 and 1. 36 is not a perfect cube. We have 4 and 9. Not a perfect cube. Perfect squares, but not perfect cubes. We have 6 and 6. We have not a perfect cube, not a perfect cube. 2 and 18. None of those are perfect cubes. We have 12 and 3. Not a perfect cube. And I think I've gotten them all. But because there's no more, then I am done. Go ahead and pause. See if you could try out 5 and 6. Pause the video. Remember, the only way to learn math is to do math. Is it a technological question? All right, so then we would, hopefully we did 3 times 4, and we went ahead and we had 12. And after you had 12, you multiply underneath the radical, and you realize, oh, it's 36. But I just got 36, and I know it can't be simplified, so I am good. Then I would come over here, 2 times 3, you had 6, and then underneath the radical, you would have the cubed root of 50. And I didn't intentionally go that way, but this is 25 and 2, this is 10 and 5, 50 and 1. How is it 50? And none of these happen to be perfect cube. I'm actually done. All right, so that's how we multiply and simplify those radicals. Our next step is to go ahead and add and subtract radicals. Now, if you remember, back in the days, just last week when we were doing like terms, if we had 2x plus 3x, I could go ahead and put those together because they were alike and I would get 5x. But if I had something like 2x plus 3y, they were not alike. And because they were not alike, I could not put them together. And so this was my simplified answer. Hope we remember. Radicals will work in a similar fashion. If you are adding or subtracting radicals, why are you having a conversation? Don't let my online fans get all upset. Okay. So, oh my God. You're messing with my likes and my views. When y'all watching the video, y'all know this pause. Y'all know why this pause is here. I'm sorry. As I was saying, I cannot add or subtract unless they are like terms. So if I look here and I look here, I realize that the radicals are the same. It is the square root of 2 and it's the square root of 2. Because they are alike, it gives me the right to add the 3 and the 4. As such, my answer is 7 radical 2. I always want to also check if I can simplify that. And I know I can't simplify radical 2, so I am done. Let's look at number 2. For number 2, ooh la la. If I look at it, I also recognize that these are like radicals. Because they are alike, I can go ahead and subtract. 3 minus 5 is negative 2, and then I have the square root of 5. And then I know that 5 cannot be simplified, it's just 5 and 1, so I am done. Let's look at something like number 4. If I look at number 4, I know I'm going to add them, so I'm going to check if they're alike. One is the square root of 2, and the other is the square root of 8. I realized, uh-oh, I can't just add them because they are not alike. Because they're not alike, maybe I'm done, maybe I'm not. Let me see if there's something that can be simplified. I know the square root of 2 cannot be simplified, but let me check the square root of 8. Factors of 8 are 4 and 2, 8 and 1, and lo and behold, this is a perfect square. So the square root of 8 can indeed be simplified. I'm going to simplify it. It breaks into the square root of 4 and the square root of 2. Well, the square root of 4 we know by now is 2. So we have 3 times 2. 3 times 2, and then we have the square root of 2. So all of this can be simplified into 6 radical 2. And then, of course, I couldn't do anything with the first one, so I still have my 6 radical 2. You can carry it down all the time, but I just carried it down at the end. So now, do they have like terms? Yes, they're both square root of 2. And 6 plus 6 is 12. So this is 12 radical 2. I'm done. Let's look at number 15. For number 15, ooh la la, they are not like radicals. So I can't add or subtract them yet. But again, they can be simplified. For 8, I just did it. So I know that 8 can be broken into the square root of 4 and the square root of 2. So that this becomes 15 times 2 times the square root of 2. That leaves us with 30 radical 2. Now let's approach the 12. Well, factors of 12, 12 and 1, 6 and 2, 3 and 4. Okay. Any of these a perfect square? No, no, yeah, there goes that 4. So this can be broken into 3, square root of 4, and the square root of 3. Well, the square root of 4 again is a number. The square root of 4 is 2, so it's 3 times 2 times the square root of 3. That means it's 6 times the square root of 3. Now, I still look. This is a square root of 2, and this is a square root of 3. Are they like terms? No, because they are not like terms. I can't go subtracting the 30 and the 6. Therefore, I am actually done. Everything was simplified. I am good to go. Thank you. Okay. I'm gonna go ahead and do these two with you as well. Keep in mind, at any moment you want to pause and try some on your own, please go ahead and pause and try some on your own. That would be awesome. Let's look at number 8. This one is fancy-ish. Cubed roots are going to work again the same way. So we have 6 cubed root of 8 plus 2 cubed root of 4. They are not like cubes. So I can't just add the two things and get 8 cubed root of something. I have to simplify them. Well, hopefully by now we recognize that the cubed root of 8 is a number. The cubed root of 8 is 2. And so this side can simplify to 12. And then I look here, the cubed root of 4 can't be broken down, can't be broken down. So then I am still just left with 2 cubed root of 4. Now you might say, can I add those together and get 14 cubed root of 4? No, because they are not like terms. This is a whole number and this is a number with a cube. So simplify them here. It would be like saying 12 plus 2x. We don't get 14x. So I cannot add those two. Go ahead and take the time to try the other problems. 3, 6, 7, 9, 10, and 11. Go ahead and try them. Pause and try them. All right, so for number 3, these match. So 9 minus 2 is 7. You should have had 7 radical 3. On number 6, I have 7 radical 10, and then I have 3 square root of 40. This is already simplified, but the 40 is not. 40 can be broken into the square root of 4 and the square root of 10. So then we have 7 square root of 10 plus 3 times 2 square root of 10, 7 square root of 10 plus 6 square root of 10, which will give me 13 square root of 10. When we come down here, we see that these are the same. So I can go ahead and add them, and I would have gotten 15 cubed root of 3. Ooh. Oh. All right, then on number 9, we have 2 cubed root of 270 minus 3 cubed root of 10. I know this can't be simplified, but maybe this portion can, and it indeed can. It can be broken into 2 cubed root of 27 and the cubed root of 10 minus 3 cubed root of 10. And so the cubed root of 27 is a number. It's 3. We have 2 times 3 times the cubed root of 10 minus 3 times the cubed root of 10. Well, 2 times 3 is 6. Oh, no.
There is a Red Pine volleyball game today after school at Margate Middle. All Thursday algebra tutoring students will come to tutoring on Wednesdays starting next week. Parents have been notified by email. The Save Promise Club is collecting